Hi everyone, we're going to talk about ionic compounds. So to begin, let's talk about ions. Now there's already a video on how to determine ions. I wanted to classify ions just a little bit for you. If you have one atom with a charge, for example, a calcium ion, Ca2+, that is called a monoatomic ion. One atom with an ion, okay? So one atom with an ion. Now, if you have two or more elements together with a charge, that's called a polyatomic ion. For example, SO4 minus 2. That's going to be called sulfate, and this is classified as a polyatomic ion. Now, ionic compounds are bringing ions together, but it's special. You bring a cation and an anion, a positive charge and a negative charge. And I have a really cool trick for you to figure out how you bring those together and in what amount. Let's take a sodium ion with a chloride ion. Now notice I did something. Sodium, the ion, is a +1. When you have a nonmetal that is has a charge, that's an ion, you change the ending to IDE. So here's chlorine, but when I put that minus charge on it, we call it chloride. Okay, now this, or each of these have a 1, +1, -1. When these ions come together and form an ionic bond, they will always balance out charges, meaning the amount of positive and the amount of negative that you have are going to be equal, so the net charge is always 0. Now here's the trick. Here's the trick. A fast, easy way to always figure out how many cation and anions you need to have a net 0 charge on that entire ionic compound. You take just the number from the cation, and that number becomes the subscript on the anion. Vice versa is also true. You take the number from the anion and cross that down, and that becomes the subscript for the cation. So these are both 1, cross down those charges, and you get NaCl. Now because they were each 1, I can leave it blank and it's understood to be 1. Just like in algebra, if I do x, I don't have to do 1x. It's understood to be 1. So I have 1 sodium, 1 chlorine. Let's do another one. Let's change this to a calcium with a chloride. Ca2+, Cl -1. So again, I'm going to cross down those charges to become the subscript. So the 2 crosses down and the 1 crosses down. We're going to have Ca, actually let's use the purple. CaCl2. I have 1 of the calcium and 2 of the chlorine. Now let's double check charge on this. You've got a +2 for the calcium, plus, now 1 chloride is a -1, but I've got 2 chloride ions times that -1, +2 plus the -1, excuse me, 2 times -1 is -2, +2 -2 gives you 0, a net charge of 0. Now let me show you how to do this with a polyatomic when we have a group of nonmetals. We're going to have, let's this time do a magnesium with a phosphate ion. Okay, so same thing, we're going to cross down charges. So I cross down that 2, cross down that 3. So the magnesium gets a subscript 3, and that 2 subscript goes to the entire polyatomic. And that polyatomic, think of it as one group that holds together, that you're not going to be able to break apart. It does a different type of bonding called covalent bonding, and we're right now putting together ionic bonds, charges. So that 2 goes to the whole phosphate group. To show the reader that whole group gets the phosphate, you use parentheses. PO4, and there's your subscript 2. The 2 goes outside the parentheses to show we have 2 of those phosphate groups. Nice. So there's overall putting together monoatomic ions and or polyatomic ions to form ionic bonds.